Welcome anybody who's new, and everybody who's been here before, welcome back. As always, we'd like to acknowledge some of our sponsors for this PyData Ann Arbor event. There's NumFOCUS, who sponsors the meetup itself. TD Ameritrade, who offers up this nice venue and space for us to be using, as well as Midas, who chips in for the food here. A couple of important points for people that are new. Emergency exits, in case of any emergencies, there's an exit right here, as well as one right through the door that you came through on the right. And also, we are looking for speakers in the future. We are kind of backed up until with a lineup up until November now, which is great. But also, please provide any feedback ongoing, things that we're doing well, things that we're doing poorly. We'd love to hear them. And also, check out our GitHub page. We tend to post our slides, as well as any other information on there. And of course, unless you have a quick question, please try to hold it until the end. And also know that you are in a borrowed space, so please try to clean up after yourselves, especially when we're getting food later on. So cups, garbage. I'd like to read the PyData Code of Conduct for us. So PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, or religion. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds. Sexual language and imagery is not appropriate for any of our meetup events. Be kind to others. Do not insult or put down other attendees. Behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the meetup at the sole discretion of the meetup organizers. But overall, thank you for making this a welcoming place for everybody to enjoy. But if you do run into issues, definitely let Ben or I know. We'll be happy to facilitate. Our icebreaker. So we always want people to be able to meet somebody beyond the company that they work for. So hopefully turn to somebody either maybe in front of you, behind you, to your left, to your right, and introduce yourselves and tell them the most interesting place that you've visited. And go.
You'll have your interesting place next week.
Otherwise,
Definitely one of the more bizarre things I've ever seen.
I only have about 3 minutes. Is that good? Okay. All right, and we're back. Thank you. Thank you. So hopefully everybody here today will have left having met somebody new in the data science space. As well, I'd like to chat about this month in data science. I don't know if any of you have heard, but at Facebook, FAIR, their artificial intelligence research group, they just announced, I guess, or opened up what they're showing as sort of the developer tools. So whether it's frameworks and tools for deep learning, as well as libraries and models, but also tutorials. and giving the community access to them. And so go check them out. It's really a great resource to have. Additionally, TD Ameritrade. We are hiring, so is Logan here? Logan Ahlstrom on the advanced analytics team. They're hiring for both data scientists and data analysts, both junior and senior positions. So make sure to check out on our careers page, so jobs.tdameritrade.com. I was notified by Dan Diebel. Dan here? I saw him earlier. But he mentioned that there's a new Julia Meetup group. So go check that out on the Meetup space as well. Is it out there? Cool. I think it's like Southeast Michigan Julia language group. So, as well, I wanted to plug next month's Meetup. So we have Leland McInnes. So I met Leland a couple of years ago at PyCon. And if anybody's ever heard of all of these different clustering tools, while Leland did not publish the original HDB scan paper, Leland was the one who implemented HDB scan. So he's coming out of Ottawa, Canada. But he's actually going to come up here to talk about one of his new pieces of work called UMAP, which is some dimensionality reduction tool that sort of competes with TSNE and the PCA space. So definitely come and check that out. Leland really gives a great and fair talk. If you've ever seen some of the documentation about HDB scan, the benchmarks are always, in my opinion, typically very fair and honest. So with that, I'd like to introduce our speaker for today. We have Travis Oliphant here. People who are used to using things like NumPy, SciPy, you have Travis to thank. So he was the creator of NumPy and I guess founding contributor to SciPy. And I learned today that SciPy actually came before NumPy. I thought it was the other way around. But Travis started that work when he was at BYU as an assistant professor. And prior to that, he was at the Mayo Clinic doing his PhD. After that work, he moved on and founded Anaconda, right? And then if you've used anything like Bokeh, Dask, Numba, right, you name it. And now I guess supporting PyViz as well and Data Shader. And so a lot of these data science tools that we all sort of see and hear about in our day-to-day, we really have Travis to thank for it, as well as the Anaconda crew.
That's right.
But he's here to talk to us about his new venture. He's recently moved on to a new opportunity called Quansight, and he'll tell us hopefully a little bit about that.
Well, I'll tell you a little about something. I had a presentation prepared that I can't find. So,
we'll have a good time.
That means we're going to talk about who knows what. And then we'll talk about, I guess I'll be just interacting live and maybe answering questions and showing some things and kind of trying to give a mental model. So I'm going to borrow from a few presentations. I've given a lot of talks over the past little while. So it's actually, maybe that's why I can't find anything. Somebody really needs to build some kind of index for presentations. It is so hard to find material you've already done before. It's a problem. So yeah, appreciate that introduction. It's a real pleasure to be here. One of the things I really love doing is going around anywhere where there's a group of people gathering to try to figure out data science, particularly with Python. But I also like my R friends and my Julia friends as well. And just trying to make sense of this. And it's a lot of fun because things are going so fast and so furious. And there's so much happening. And I like to start by giving a little bit of context because I know there's so many more people that have gathered to these communities than used to be here. Right? There used to be a lot of shared knowledge, and some of that shared knowledge has drifted. Like, it surprises me that people think NumPy came before SciPy. Right? And I guess it makes sense logically. But the way NumPy came about, because it was a merger of Numeric and NumArray. And Numeric existed, and I wrote SciPy on top of Numeric. I started that project basically as a grad student. So instead of doing my PhD like I should have done, I was out writing software. And that actually played out multiple times. Fernando has the same story. John Hunter had the same story. Several people had that story. So we have, procrastinating PhDs to thank for a lot of work. But I really enjoyed doing that. I have a little bit here. I think what I'll do is maybe start with a little bit of that story. If I can go to, I just have a tiny little bit of it, and this is right. So I was in the Mayo Clinic studying, Star Trek medicine. This is a professor that inspired me there. He wanted to figure out how to make, medicine like Star Trek, and we were doing AI back then, or trying to. I was doing basically a Parson window density estimator to try to figure out how to register two images together. There's a lot of really cool stuff we were working on way back then. Now, with computing, we had to deploy onto 15 different Unix versions, HPUX, and different from Sun and from all these other AUX. There's a lot of platforms we had to deploy to. I was really doing science. I still consider myself first and foremost to be a scientist, to be somebody an engineer and a scientist who I love applied math. I love to figure out how does data lead to something when I have a model. So very curious about those things. I love neuroscience. I love reading the latest advances. That led to Python. It was that quest to try to make science faster and better that led to, well, how do I do this? I was kind of writing all my code in MATLAB, and I didn't like the fact that when I shared my code with somebody, they had to have a license for this other software. And I thought, surely the world could be better than essentially giving somebody code they can't use until they buy something. I'm not against buying things. It didn't seem right. It felt like literacy was important. I didn't want to, here's a library, but before you can open this book, you got to go pay somebody to read this. Like, that felt really wrong, even though I find selling books. That's great. So I came to Python a long time ago, right? January in basically 1996, 97, but it was 1.4. How many remember Python 1.4? Let's raise your hand. Yes, all right, we've got a Python 1 version. A few years ago, when we started Anaconda, we had a little April Fool's joke. Actually, Python was known for its April Fool's jokes. It's kind of funny. It was known for a long time. So we put out one a few years ago that was, Conda install Python 1.0. And you can still do it, actually, because you can play with Conda Python 1.0. I was 1.4, and it was a lot of fun. I so was excited about 1.52, man. I remember the way I felt, like, oh man, Python 1.52, it's so much better. And it was. And then Python 2 had huge strides. And, this is back when PyCon, who's going to PyCon, by the way? Anybody going to PyCon? Anybody want to ride to PyCon? I'm driving there tomorrow, so if you want to ride, let me know. We can have a great talk on the way down to Cleveland. But it was back when there was about 20 of us, right? Maybe 30. And we just kind of gathered around as also a workshop. And now, of course, there's 3,000, 3,000. There's a lot more people, and it's bigger, much, much bigger. But you still get a chance to talk with people, and they're just regular people, just people interested in solving hard problems. So I started with SciPy, and it really was kind of procrastinating my work, kind of because I thought, well, I really want to use Python, but it needs tools. I need special functions. I need to be able to write Bessel functions and be able to calculate them. I needed integration. I needed ordinary differential equation integration. I was simulating MRIs, and I needed to be able to solve an ODE. So how do I do that? Well, there was Fortran code out there that did it, but I didn't want to write Fortran all day. But if I wrapped it once, then I could call Python, and it would use the Fortran to do the work. So I kind of became really, really good at wrapping scientific code. That was basically my one skill set. Then I had friends, fortunately, who don't let friends wrap Fortran code manually. And one guy in particular really kind of stepped up and helped me, because he saw that in 1999 I was just one series of posts after another. I went back to the mailing list archive and looked at it and went, man, I really didn't do much work that year, did I? Tried to hide that from my family. Like, no, I was getting my PhD, not just wasting my time. Spending on all these tools, but I was so addicted. I had so much fun. It was this before Facebook, before Instagram. The way we shared ourselves is we would write code and put up an ugly-looking web page, and people would download stuff. And it was boring back then. But no, it was really fun. People all over the world would download it, install it, and then send back information. Diff files, not pull requests. They would use the patch command, and they would send it. It was a little bit more work, and you'd send an email with a diff, and you'd have to take that diff and figure out if you could apply it. But that's how we did it, and we made progress. So all of these packages came out kind of one by one early on, and there was no packaging. So packaging was a matter of tarballs, build, install, and see and pray. Hope it works. And then actually a guy named Robert Kern, who is still active in the SciPy community, ended up making a bunch of Windows installers for all this stuff I was doing. And man, then people really started to use my stuff. So that was the first kind of awareness of, oh, actually packaging matters. If you make it available on Windows, then you get users. And that led to a lot of extra work. So I used numeric, but I actually gave this talk in I used these slides in Estonia and met my friend Piaru, who was in Estonia, and he was huge in making SciPy come together. So Eric Jones had some libraries. I had a bunch of libraries I'd written, and Pyaru had F2Py fundamentally. He saw these things I was manually doing and said, you're never going to wrap the world's Fortran one by yourself. So being a computer scientist, he went and wrote a tool to do that. Right? You've all seen the XKCD comic where they pass the salt, and the guy's like, hey, pass the salt. Hey, I'm working on it. I'm like a script to pass the salt. It'd be great. No, I just want the salt. I was actually the guy that just passed the salt multiple times. I was a little more pragmatic, I suppose, and I kind of realized that I was more a scientist than a computer scientist because I just wanted to get stuff done. But Pyaru was great, and he wrote this tool to wrap everything. So we're working together again. I'm very excited to have him working together again on the next thing I'm doing with XND. So I read a lot of packages. Then basically in 2001, NumArray started to rise, and it was basically it was a person out there wrote something called ND-Image. ND-Image had these cool morphology, binary dilation, erosion, open and closing. Everyone's done image processing with those kind of operators. He wrote that tool, but it worked on NumArray, and it didn't work on numeric. And I had SciPy, and it worked on numeric arrays. And so I was really frustrated, like, I'd have to copy my data from numeric to NumArray in order to use this tool. It really felt ugly. It felt like, what kind of world is it where we can't write operators and have them work on containers, on arrays that are I already have my data in this container. I have to move it over to some other container in order to do this operation, which should, by all rights, be able to be applied to the one I've got. Why can't I do that? Well, because that's the way it was working. So I said, well, what if I just wrote something that merged these two? I got some free time. I've got a month or two free time. Surely I can do this in a month or two. So that's what I did in 2005. Was I basically had a class. I was teaching university, and nobody showed up for it. It was basically a software radio class for building an MRI, and I only got one registrant, and then they dropped. And so I sort of didn't tell anybody. Had some free time, and so I said, well, I'll just write this thing. And so I dug in, and I basically took the features of NumArray and poured them to the code base of numeric, and spent about 6 months and had a working version, and another year making it actually really work with all the bug reports that came in by those first brave souls who started out the first year. And so that was NumPy, where it came about, 2005, 2006. And of course, the key to any open source project is that it obtains a community of users and developers as well, contributors. No open source project I'm aware of actually succeeds alone. It definitely requires a small group of people to move it forward, 1 to 3, maybe 5 people to get it started, but it does not succeed unless there's enough people who pay attention and care about it to move it forward and get many contributors. And that process, you see that over and over and over again. But it's still basically a power law. You look at the number of contributors, and I think there's about 5 to 6 people who actually maintain NumPy now, even though there's 609 contributors or more now. There's a bunch of contributors, but only a few who actually are there. And one of them is not me anymore, right? So about 2012, I kind of backed away. I really don't have time, so don't expect anything. Don't expect me to be able. I can weigh in on occasion if you need something, but fortunately, there's some really great people. Charles Harris have stepped up. Stefan. There's a bunch of other folks who have jumped in. Daniel, who are maintaining, right? And that's a lot of work to maintain, and it's very important work. SciPy was another thing. So SciPy, I kind of stepped away from SciPy in 2009, 2010, because that had started in 1999, right? So these were my babies for about 10 years. And then I had to, basically, I wasn't able to provide for my family and work full-time on open source, right? And so that's basically been a personal thing. I've been really like, how do we make this work? How can we actually make a world where people can work on open source and still have a job? Now, it is starting. I mean, there actually turns out to be a lot of ways that happens. And so, but not always for this group of people. NumPy and SciPy are still a lot of people do it on their free time. They kind of take it from their employers a little bit. Like, employers aren't really, you work on this half full time. So it's a real. I tell you that story to kind of give you an insight into why do I think about this. I've been caring and thinking about sustainable open source since I was a young graduate student with 3 kids, making $18,000 a year, trying to figure out how am I going to provide for my family and still do this thing that I love, which is collaborate on open source software with the world. How's I going to do it? And I'm still trying to figure that out, to be honest. Experiment a lot, done a lot of different things over the course of those 20 years. But I think we're coming across things that actually work and some ideas that work. So This is a preview. I'll talk about this a little bit later after I talk about kind of what this has led me to today. One of the projects that we're working on at Quansight, and I've been kind of under at Anaconda previously, we were working on this really kind of with one person, really not much of a funded effort, but a little bit of effort. About 3 years ago, I had an idea, and it actually was a little earlier than that. But since we started Anaconda, and I left. I was working on NumPy from 2006 through 2012, off and on, trying to help the community, help things work. But of course, over that time, I saw it used by millions of people. Knew personally thousands of those people. Saw the opportunities and challenges they had with it, and said, things here aren't. There needs to be fixes to these things. When it gets applied at scale, there's challenges. So all kinds of problems. Had a whole list of them in 2012. And I give talks about these are the problems, how do we fix it, but didn't quite know what to do, right? Because how do you fix how do you take something that's used by everybody and then tweak it to make it better, right? It's really hard, turns out. Microsoft, everybody. There's two answers, right? You either iterate slowly and improve things slowly, or you build something new, right? And I think you can point to historical evidence of both of those. I tend to think in NumPy's case that to really get it to be where it needs to be for the world ahead of us, to get the same capabilities but in a different setting, it has to be refactored and has to be rewritten. That doesn't mean NumPy is going to disappear. What I think is going to happen, and I'll explain kind of my thinking as to what I think is going to happen. Now I put NumPy 2.0 here in quotes or parentheses because I won't decide. I'm not in charge of deciding what happens to NumPy. Right? NumPy is a community project. It's governed by a steering council of people that have to agree on what happens to NumPy. Right? So I don't have an opinion. I might raise it. I can voice a view about what we ought to do, and I can even put a prototype together. But NumPy won't move unless all those folks agree. Right? It's got to be kind of a unanimous decision. The way I've seen that work in the past is basically people move when things work, and so it's a slow process, which is really good if you're relying on something. It's sort of a way to have maintenance and a way for things to stay very, very stable. But it can be very difficult to innovate in that environment, actually. So, but I think that's okay. I think that open source provides the ability to kind of have both strong things that are stable as well as opportunities to innovate in other ways. So I'll talk a little more about XND and kind of this project that we've been working on that we're going to be coming out with. Sort of PyCon will be the first time we're talking about it. I just got a website up, XND.io. The project, the GitHub's been going on for a couple of years, but we've had one person committing quite a bit to it. And then we're starting to get a team around it. There's about 3 people now committing fairly regularly to the project. And I'm really excited about where it's going to go and possibilities for what we can do in the future with it. So that's one topic we'll get back to and I want to talk more about. Are there any questions on kind of the history of NumPy, SciPy, anything else I can address there? Yeah.
Well, I just had a question about your slide, the central, I don't know how you say that, is it GU math? Or
GU math.
GU math?
Yeah.
Okay. Is that new or is that already been out?
It's new.
Okay. I recognize Numba, but I don't recognize.
Yes, correct. So Numba is the only thing that is really used here. All these are new. So LiveNDT, data shape is older. LiveNDT, data shape, any types, GeoMath, XND, data fabric, all those are new. Lineage, O-random, those are all new. The only thing that is out there is Numba. And the point here is basically saying, hey, we've got a compiler now. We can rethink how we do this. We've got a JIT compiler in Python. Numba lets us just write Python code and get machine code. And like I've said multiple times, if I'd had that in 2000, back in 1998, 99, when I was writing SciPy, I'd have written things a lot differently. Things would have been a lot different, actually. And so it's a powerful tool that's available now. And Numba has taken a little while but it's not quite at 1.0. It's trying to reach 1.0 this year, likely. I don't know. Do you have any updates, Ben? Have you heard from them? I talk to Stan pretty regularly, but it's a powerful tool. And what's exciting is that Intel and NVIDIA and other vendors have started the vision of it was to create a platform where vendors could make it work for their hardware, and Numba's starting to do that. So I'm really excited by that. Numba was one of the projects we started when we started in a Continuum, and it's really exciting to see it kind of reach its potential. Still got still more to do, but it's exciting to see that happen. All right.
Explain for people who don't know what NumPy is.
Sure. Yeah. Numba. Who knows what Numba is? Raise your hand. He does. Thank you. Great. You don't know what Numba is? Oh my goodness, you're going to be so happy if you're a Python user. How many know what Python is? Raise your hand if you know what Python is. Just making sure. Right? Do we have to go there? Right. So Numba is a compiler for Python. It takes Python code and creates machine code out of it. So different than like a tracing JIT, it doesn't try to like sample your code and decide for you when to compile it. It basically is you decorate code and it converts code you decorate to machine code. So it's kind of a runtime ahead of time compiler for numerical computing primarily. Like it really doesn't help you make your dictionary of lists of dictionary objects faster. Like if you've got if you're using Python and you have very these deeply nested structures of dictionaries and lists, and you're using all that in direction, it's not going to make that faster. But if your data is stored in columns, it's arrays, and you're basically doing array indexing on those kind of data sets of typed data, it can make that code as fast as C. It's as if you wrote C code and you're writing Python loops. And so it's really quite interesting because you can write very simple code and have it very, very fast. I can give examples of that actually if we have time. I actually was surprised. Like that's really cool. You'll treat yourself to some Numba, I'd say, right? It's really cool. When you start to realize, oh my goodness, that's possible. One of Lorena Barba is a friend of mine who teaches at George Washington University, and she has a course. She gives a talk. Basically says, "Tell your C++ bullies to go home," right? Because she gets some flack. People, all right, the C++, because it's the only way to get speed. And she's going, no, look at this. I got Python code, Numba, fast as your C++ code. It's true.
How is it different from
Python
Python?
is there's use cases where they overlap. They can both be used together, but they typically have different use cases. Python is typically used to build an extension module ahead of time where you specifically give it types. So Python, you give it types. I think, why don't I, actually I don't, but I can quickly get it, I think, if Ben's stuff is still working for me. So Conda install Numba. And I don't have interconnect. This has been dropping. I'm now on a different network. I've been having this trouble. It keeps dropping my network. How many people are Conda users here? Okay, that's better. Good. You'll all have an easier time installing Numba. Now, you can pip install Numba now, but it's really, like I tell, when you're pip installing a complex C dependency, you're just sort of giving yourself technical debt to unravel later. Right? I mean, it may work, and it'll work fine for a little while, but unless you've really structured it well, and maybe inside of a Docker container, and you're architected it well, the internet is really full of information that's going to cause you technical problems later. It's unfortunate, really, but it's what's happening. It's kind of a consequence of the big benefit of Python is it brings all of us together. The web programmers, the system admins, the kind of computer science programmers with scientists and array people that would use MATLAB otherwise and Fortran. We all come together into Python, but we think a little bit differently. And when you go to PyCon, it's very clear. Jake Vonderplas gave a great talk about the different diversity of PyCon. You may meet people you don't understand. Unfortunately, the packaging community in Python has been a little bit one-sided. And they've kind of, Nick Coughlin has been very, very good at communicating about how this, the purpose of pip and where it fits and how Conda plays a role. But there's been others very, very super excited about kind of thinking that pip is going to be how you package the world. And it's not. And it's not. It can't work that way. And so people get into trouble when they pip install only. So Conda it's more like yum and brew and apt-get. So if you think of Conda, you think of actually instead of using brew or instead of using apt-get, I'm going to use Conda. And then I can use pip as well on top if I need to. But that's the way you got to think about it. Conda and pip aren't competitors. Conda and brew are competitors, right? That's the right way to think about it. To install Numba, It depends on something called LLVM. LLVM is a compiler toolchain that is used in Clang, which is a C++ compiler. So you effectively have a compiler, right? Knows nothing about Python. LLVM knows nothing about Python. So you have to install that somehow, right? In order to run Numba, you got to have LLVM. Conda can install LLVM just fine. Then it installs a wrapper called LLVM Lite, and then with that, you have the makings of a tool that lets you compile Python code. So now that I have it installed, let's go to my Jupyter Lab session, and this is really small probably, right? Is that better?
Anybody in these back couple rows are having a hard time, the screen is on back here, so you can see it.
Oh, it's back there? Okay, yeah, cool, very good. So basically, you just have this very simple ability to write a function, and I'll do two kinds of functions. I'll do a function that just basically returns x. Let's do if.
Maybe a bit bigger, Travis.
Okay, thank you. Is that better?
Maybe one more if you can.
How's that?
Cool.
Right, so there you go. There's your little function, right? So this function is meant to take two integers and then just basically compute the absolute value, effectively, return the difference depending on which is greater. So I can, from Numba, there's a little thing called vectorize, and this is what I always wanted when I was writing NumPy. I wanted something that would take Python code and give me what's called a universal function, or a map, that would work over all elements of an array and use the same broadcasting rules that add and sign and every function, all these functions in NumPy do. And Numba gave it to me. We iterated a bunch to get it, but we basically went and wrote a tool that would take Python syntax, convert it to LLVM, and compile it to machine code. Just like Clang takes C++ syntax, compiles it to LLVM, makes machine code out of it. It really makes Python on par with C++. Now there's some nuances there because, okay, wait a minute, well, there's no types here, so how do you manage that? Well, you actually don't create machine code until you call this with something. So I have to first, make an array of, let's just go 1 to 100. Y1 equals, let's do X1 backwards. Right? So it kind of gives me the negative absolute value, right? The way I've done that. So that vfunc, now what if I just called func on x1 and y1? What do you think that's going to do? It's going to give me an error. It's going to say, wait, x less than y, x is an array, and y, I don't know what to do. I don't know what to do. I don't know what this means. X less than y doesn't work. It needs, so what vfunc does, it translates a scalar function to what vectorize does to a function that'll work across the array. But it compiles it to machine code. So this is fast. And it's as fast as, you can make functions very, very fast that map across your array very, very quickly and very easily. That gets really neat when you start talking about generalized vfuncs, which are kernels that work on array chunks. So using vectorize, you can think about your data as arrays, chunks of data, and little kernel operators that work on chunks of those data. And when you think about your data that way, it turns out you think about the data the same way the computer wants to think about the data. And therefore, you can write very fast code. One of the problems we have today is that a lot of computer science teaching has taught people to think about their data differently than the way the computer thinks about it. They've taught them to think about it in terms of objects scattered all over memory. And then the computer or compiler world has to work really, really hard to even do something with that and make it fast, and it doesn't always succeed. In fact, it rarely succeeds. That especially becomes problematic when you're talking about GPUs. With Numba, we can take this function and actually target the GPU or target parallel, and we can run it in parallel, run it in GPU. So with Numba at your side, you basically, people tell you, oh, Python, it's got the GIL, it's not parallelizable. You go, what are you talking about? Numba, target parallel, I'm using 10 cores. But you have a tool here, very simple code, very simple modification if you're using NumPy arrays or array constructs at the same time. So Numba is a powerful tool. It was the idea came from initially, and it's been making rapid progress. And it targets GPUs. It's the easiest way to program GPU I know about. So that's the easiest part. Then you can just do general things like you can just JIT code too. So the purpose of JIT would be if I had a loopy function and I had an array like this, I could do a for loop for I in range A, length of A like this. And just do something like actually let's do result equals empty, empty, and then okay. And then I got to return something. Okay, so then you get just a simple for loop. Not a problem if my loop is like 100 elements, right? I can do that. But what happens when it's 1,000,000? And what happens if I have 2 for loops inside of each other, or 4 for loops? If you're doing a convolution over a 2-dimensional array, you never do that in Python, right? Well, if I can vectorize, if I can JIT that and compile it to machine code, sure, no problem. And that's what you have. Numba also has a JIT. So Numba JIT, you hand in loopy. So these are used as decorators over functions. They give you new functions, fast loopy. Right, and now that is working over the entire array. But now it's in machine code. Right, so you basically can, and there's some work it has to do there, because if you look at this code, this is a template. There's no type information. Back to your original question about Python. Python is similar, except you have to tell the types. You have to say, oh, this loop, this I variable is an int. This A is an array of types. So it gets really bulky. Numba, it infers types for you. It understands, oh, I called this with an array of type float, so I know that this must be a float type. I have a loop index, that must be an integer. It infers those types and generates machine code accordingly. So it's type inference, automatic kind of construction of machine code. It's powerful. It's a powerful tool. It was actually took about 2.5 years to write something that was actually fairly usable, maybe 3 years. After 3 years, it's kind of usable. I know, Ben, maybe keep me honest.
Fights between AST and
yeah, we had fights about how to do it and how to write it. Exactly. The idea was pretty exciting for a long time, but if you haven't used Numba, Numba is actually the heart of a lot of the things you see coming out of Anaconda, like Data Shader. Data Shader uses Numba under the covers. You look at Dask. Dask is a parallelization library. I won't go into that, but definitely should look up Dask and make sure you understand what it is. Dask is Pythonic Spark, right? So Dask is kind of what would happen if people looked at Spark and said, how should you really do this in Python? I've said to people, PySpark is a gateway drug to Scala. It is, right? I mean, because you basically are struggling with PySpark and pretty soon, I'll just go to Scala. Then you're like, I hate myself. Why did I go to Scala? Right, but it kind of does take you down that path. Dask is kind of like, well, if I'm actually using Python, what would it look like? Oh, it'd look like this. And you're sort of, now it's, lights turn on, you feel like it's Pythonic, you're happy. Until your administrator maybe is giving you grief about starting Dask workers. Fortunately, that's getting easier and easier, but it's really a powerful tool. You combine Dask and Numba, now we really were able to solve kind of one of the fundamental problems we started continuing to do, was to scale out Python. Dask and Numba give us a scale up, scale out solution that really you can take Python and go a long, long ways. So pretty exciting, actually. Definitely one of the things I'm happy about.
So you don't have to put any decorators in yourself, is what you're saying?
You don't.
You don't have to.
You can. Yeah. All a decorator does is a syntactic sugar for that operation. Right. And, go ahead.
So what's the reason that you use that you would write it how you did with Loopy and use JIT versus writing it how you wrote the negative absolute value.
Yeah, it kind of depends on what you're trying to accomplish. So JIT is the most general. Like JIT, you can write any for loop over anything and structure it how you like. Vectorize is, okay, I'm going to write a kernel over an array. And it kind of, that's less general, but sometimes easier to think about. Like you effectively, the code writes that outer loop for you. And it does it in a way that's consistent with how NumPy writes loops, and really when it combines loops. Like the power is you get the same kind of object that Python itself uses, or NumPy uses to do addition and subtraction, the broadcasting basically. If I have arrays that aren't the same shape, it gives you the same capability. So it makes it a way to make ufuncs.
Is there a performance difference between
No. Well, yes, Vectorize will be a little faster sometimes.
Way to use NumPy
On
on smartphones?
smartphones? Not presently, not that I know of. I mean, theoretically, but
The package was Android with Java.
yeah, you'd have to basically. I don't know of a target. We haven't targeted. I haven't seen it targeted to smartphone platform. You have to have Python there. You'd have to have. I guess you could cross-compile potentially. You know, with LVM, you could potentially think about cross-compiling. You know, producing machine code that would work on a phone. That would be possible, but it certainly isn't out of the box something that is easy. Right? It would take some elbow grease to make that happen. But you could get a handle of the code that's generated from the Python code that Numba produces of LLVM and just retarget smartphone code. Absolutely could do that. You just have to dig in and probably use LLVM Lite, the underlying tool underneath the covers. Yeah. Good question. Yeah?
Not to get too in the weeds, but I've seen this before in C where it becomes a template problem because you don't know the D type of the array that you're dealing with. And so you dispatch based on type, and you end up having a different version of Loopy based on each type, possible type.
Correct.
And at the high level, it dispatches.
That's exactly what happens here.
Okay.
This is exactly what happens.
But do you end up having an n squared problem if you are trying to add two arrays and you don't know the types of either one?
So it basically constructs a version for if you pass in a float and an int, it'll construct a version for float and int. And if you could put an int float, it'll construct another version for int float. And, you know, it basically does exactly what you asked for. So, yeah, you could have like all of them. But in practice, you don't because you build what you need for your use case.
Oh, because it's JIT. It's after the fact.
Yes.
Once it knows the types.
Correct. So the big difference is NumPy had to pre-compute ahead of time all these loops, right? This just computes them on the fly and then caches it and stores it. So you can actually have you could have a NumPy that uses Numba that was a lot smaller. Didn't have those pre-compiled loops because it would just compile them and cache them as you needed to. So it's a lot more, a lot simpler, right? There's a lot of problems that it solves that are. I'm kind of excited by. Presently, I'm thinking a lot about the web as a platform. You know, WebAssembly is emerging, and you think about, compiling using Numba to compile to WebAssembly and having in-client, in-browser executables. I think it's entirely possible over the next 2 to 3 years we'll see a lot of in-browser runtimes. It's a different runtime, different experience, a little bit like the phone conversation. Browser's probably closer to the phone. I mean, you might see it in the browser, and then the browser is how it gets to the phone because you have WebAssembly on the phones, and somebody takes care of that computation. Yeah.
What about systems that didn't use Python, but use like C++, C, and can you just compile it with Python?
So you wouldn't need to necessarily. I mean, typically the C++ produces machine code, then Python steers that machine code. Right, Python's very good at gluing that with the rest of it, and then having a kind of a combined system where it's all working together. That's usually the way it works in those cases. All right, let's see if we can move on a little bit. Sorry, but that was fun. Actually, Numba, I love Numba. Numba was one of the things I was so excited about. We spent a lot of time on it, and I don't get to spend as much time with those folks anymore. That was one of the downsides of starting something new. But it means I get to do some other things too, so that's always fun. I want to give you a little window into what I'm doing now, just because, like I said, the problem of sustainable open source is a personal something I really care about. And in fact, one of the, Anaconda, Continuum Anaconda, we were very successful at creating a lab, kind of an innovation lab that had, at any one time about 30 people who were working on open source software, some of which was pretty, directly tied to Anaconda Enterprise, our Anaconda product story, and some of which was not really directly tied. It was more broader and kind of supportive. And that partly because the product story emerged after the fact. We had a big, broad mission, and the product story emerged that was smaller and more narrow. But I love the fact that we had this sustainable story. We had this sustainable lab that we built, and it was doing a lot of great things, and super excited about that. So basically, when Anaconda sort of focused its energy around the enterprise software story that it has, the board and I agreed that I would spin off another company that would basically continue the broader mission of supporting open source, doing general purpose consulting to do that, and that's Quansight. And effectively, the way I look at this is Continuum gave rise to Anaconda, and if we structured it right to begin with, we would have spun out Anaconda as a separate company. But it's kind of in hindsight hard to do that. Once you get a bunch of investors around the table and a bunch of stakeholders, you have to kind of some things you can't unravel that simply. So we start this one, Quansight, we've organized like that. It's basically an incubation services company that sustains open source, it's a lab, helps people fund open source, and then we look for product ideas. And as we find them, we'll spin out new companies, right? So you go to our website, quansight.com, and there's a story for multiple people. There's a story for community members, a story for developers who want to work with us. There's a story for entrepreneurs who want to come and help spin out companies using our model. And then there's a story for what are we selling today? What are we doing today? We basically do three things as a company. We grow talent. We build technology, and we discover products. We grow talent by working with people and recognizing that it's not a university degree. It's not 12 weeks in a boot camp that make you a data scientist. It's on the job working with people that know what they're doing. And that apprenticeship model, we're just embracing that. If you're in medicine, the guys of a teaching hospital, that's where doctors are really made. They're not made in medical school. They're made in the teaching hospitals. And we're basically building a teaching hospital for data scientists, or a teaching environment. So we mentor data scientists and get them paired up. We have a Quansight Labs, an OSS dev team. We work on whatever, like a lot of projects. Really, that will depend on the people that join us and what they're interested in. If you look at Continuum, what it got interested in, there's a few things we started with, but it kind of grew based on the people that joined and what they were passionate about, what they wanted to grow. Then we do general services to fund this. We work for people, and we do work that they need done. So that's a big deal. We've just introduced this model. It's kind of something I've seen at H2O, I've seen it at Continuum, and Anaconda, I saw it at TypeSafe and other companies. It's basically recognizing the need for a transmission, for a quarter wave transformer, for a group that connects companies to open source communities. And there's a lot that can be done there, so we encapsulate that in what we call the sustainable open source subscription. We go to companies, help them understand how they can get the things they need out of open source. They can find people to hire who are around these open source projects, and then they can mitigate their risk associated with open source, among a set of other features. Those are the three principal ones. And that's what we do for companies. That's what they pay for. For communities, we help them organize their roadmap and organize what they want to accomplish and present it in a way that can be funded. And so we kind of we're a market to connect the open source communities with companies. Super excited by it. We're having some success already. We're just barely started this, a few weeks, but very excited about this. That's kind of what we're after, what we're doing at Anaconda. My next iteration on figuring out how to help sustainable open source is this model. So if you work someplace, you think you're using open source, think your company might be interested in helping this effort, give me a call. Let me know, and we'll have a talk. Yeah.
So the open source projects that come out of this, is there do you have a website there that you would go to see these? Or
yeah, so some of this is funding open source that already exists, right? So I would actually expect there'd be a 10-to-1. We'd support 10 projects, and then one might be new, right? Maybe it's 5-to-1. I would expect. It's to sustain other products that are there, help organizations use those, as well as start new ones that help organize data according to the way people believe it might happen. So that's kind of the model.
Are these projects going to blend with Anaconda?
Absolutely. Yeah, absolutely. Yeah, our default is to make a Conda package, right, and make it available and accessible in the Anaconda ecosystem. Yeah, absolutely. Now, obviously Anaconda will manage that themselves, right? So this is an example of the kind of, we make brochures, we talk to the communities, organize their roadmaps, and we're just starting this process of effectively writing marketing and sales playbooks around open source roadmaps. So super excited by that. That's what we're doing. And it kind of adds on to the work we did when I started Continuum, which became Anaconda. NumFOCUS, we also started NumFOCUS, which continues to go. And it's basically it's an organization that fiscally sponsors these organizations and helps them maintain their community spirit. It's really important that at Quansight we honor the communities as they exist, and we help them be those communities. We don't come in and say, we're going to take over your governance, we're going to take over how you do this. No, in fact, we're going to help you understand how you do this, how the communities want to do it, and maybe facilitate conversations between people that maybe things get stalled because the conversations aren't happening, people are just not talking to each other. We sort of help that process along. Kind of using the experience we have in doing that. So if we think about the projects we're interested in, I will finish by telling you, and it's probably right, I don't have enough material to go into more depth. I'll talk about XND. Like I said, in NumPy, we found out one of the principal problems of NumPy was the type system could not be extended very easily. It's also very tied to the Python C API. So everybody who wanted to use PyPy or Jython or IronPython is really hard to get access to that array computing because they had to re-implement the Python C API, and they didn't do that. And it became a stumbling block for every one of those other alternative views of Python to work. So the idea of XND is basically say, look, we're not going to rewrite NumPy. We're going to take the concepts of NumPy, break them apart into independent libraries, C libraries, that can then have C libraries that are cross-language. So R and Julia and Node and WebAssembly, other things can use those libraries to implement basic concepts. And then have Python interfaces that are the principal ones that are libraries that can be used by anybody doing array computing in Python, including a NumPy 2.0 perhaps in the future. But most particularly in the meantime, it's things like Dask arrays and Xarray and pandas potentially. There's a lot of people out there using NumPy under the covers who could be using libraries instead. There's a lot of learning we did. One of the principles of learning was that NumPy acts as a user library, as a user interface sometimes, like a thing you as a data scientist will interact with. Initially, that was its intent. As the years have passed on, it's actually more like a library now. But how you write a library in Python is very different than how you write that final application layer. And so there's some things in NumPy that kind of smell weird because they're, if you're using it as a library, you're like, wait, why are you doing that? Just raise an error, give me back do this quickly. So there's kind of learning like that we're applying. But the big thing is the type system. So we start with ND types. And ND types is basically just a simple way to, who's heard of Arrow here? What's exciting to me is that, Wes and I are saying the same thing about different things. He's basically saying the same thing about pandas that I'm saying about NumPy, which is basically we need to write about containers that are common across languages, rather than having Python as a data frame and Python has a NumPy array, and then Julia has one, and then R has one. No, we have a common way to talk about container data, and then interfaces to it from different languages, so that we don't have to copy data around just to simply do computation with another language.
Yeah. How would you compare and contrast those two?
So what's Arrow and XND?
Yeah.
So how would you compare and contrast NumPy and pandas?
Same. Yeah. Okay.
So NumPy is to XND as pandas is to Arrow is the way I'd say
Gotcha.
it. That's the simplest way to understand it. XND tends to be more. My hypothesis is that we can describe an Arrow container with XND's type system. So the Arrow container is a kind of shared container. XND can basically represent many, many kinds of containers for all kinds of data structures. And then there's the question will there be computation systems built on those type systems? I'm not sure, right? Because are you going to the ND types is much more general. ND types can describe pointers to data structures of all kinds. They can describe linked lists. It can describe but pretty much it's intended to describe blocks of data. Now, GUmath is about, and so XND is then basically a pointer to a memory block and a description of that memory block with NDT, with ND types. Just like a NumPy array has a D type that describes it. How many folks are familiar with NumPy's D types? So I have an example here because it's just a very simple example, but kind of illustrates, before pandas existed, people kind of were enticed by these structure arrays in NumPy. You had this ability to find an array of structures. I could have a type that itself was a string of 10, an integer, and a float. And if I have an array of those, it kind of looks like a data frame. It's a little different, though, because it's all one contiguous block. It's an array of structures. The difference with a data frame is you usually want it flipped. You want a transpose of that. You want a structure of arrays. You want the integers all together. You want the floats all together. You want the strings all together. The structured data type that NumPy provides gives you records all together, right? You have a string, float, and then you have another one. It's more row-based. And so it's not always what you want. But it does give a very compact way to describe data. And you can basically point to that data. And with XND, by adding a reference data type, by adding a pointer data type, we can now basically construct a structure of arrays as well. Because we can have a pointer to an integer array of 10. We can have a pointer to an integer array, a float array, and you can basically describe a pandas data frame. Now, do you have a computation system on top of that? Well, if you write one, if you register functions that work with that, then yes. That's what GUmath provides, is a mechanism to create registrations of functions that work on those type systems. Yeah.
Would this plug into Odo? I was going to say, a lot of people don't know about Odo.
Yeah, they don't. Not necessarily. Odo's really cool, actually. It's the one part of Blaze that hasn't been yet salvaged in something else, right? It's kind of orphaned right now. It needs help. It's one I hope to be able to kind of reconnect to something that's more maintainable, because it needs to be refactored in order to continue. But yeah, Odo's a cool tool, right? It uses some of these ideas, but not really. It's kind of separate. Odo is more. This is more about description of the data type. Odo is more about high-level semantics of, interfaces to serialization code. So it's getting into the weeds. I realize there's a lot of detail here, but at the end of the day, XND gives you, at a high level, the ability to have arbitrary containers of arbitrarily typed data, and then a function system that lets you define kernels and find functions that work on that. We'll use Numba in order to generate those kernels. So very quickly, we can basically build operations on any kind of data, strings, pointers to strings, arrays of whatever you like. It's all accessible. So the infrastructure is there. GUmath, and this GUmath is very new. ND types we've been working on for about 3 years. XND came out basically in December, January. GUmath is just like the last few weeks. So this is very, very new, and there's lots of work to be done. Don't expect to see this in your bag of tools for at least a year, I'd say, right? If you're like a user, hey, when am I going to be able to play with this? Yeah, a year, maybe. If you're a developer and want to play with it, you can do that today. If you want to use it as a way to kind of play around and see what you can do. So that's XND. That's what I'm working on now. A little bit of history of where I've been and what I'm doing now. Love to take questions and kind of talk about what you'd like me to say for the rest of the time.
Yeah. So we have time for a few questions. Have we asked enough?
I have an unrelated question. Do you have any connection to the famous cartoonist?
I've looked into that. I don't think so.
You don't think so?
No, I don't think so.
So you don't know Pup then?
No, unfortunately.
Yeah. All right. Never mind.
Yeah, I know. Isn't that horrible? Yeah, that's barely even useful of a response. But I will point you out to something. Be one of the first people to look at something we're rolling out at PyCon. We're announcing. So in this process of doing open source development, bringing to companies opportunities to fund open source, we're going to need a lot of people who want to either be freelancers or work for us full time to work on open source. And so the way we're doing this, we have a website, OpenTeam, Quansight.com. There's basically and if I can get Wi-Fi anywhere. Ben shut me off. No. Anyway, go there. It's very, very minimal. It's basically a way to register. Hey, I'm interested. Here's what I kind of need to make, and it's all private, GPDR compliant. We'll erase it if you want us to, but it gives us an idea of who's available, where they need to be working, it's kind of building the database of hey, I'm available to work on open source. So this is me, and if you go there as you'll be able to log in and decide and tell us where you can work, what you need to be paid, and basically raise your hand and say I'm available. So go ahead and that's it. That's what I've got.
Any other questions? In the back, in the front. Please.
You had mentioned Wes McKinney and Pandas and like Arrow, and I was curious if there's any sort of more formal involvement between any of like the projects that you're in right now, and like you just started this Universal Labs thing.
Absolutely.
If there's anything more sort of formal.
So Wes and I know each other really, really well, and we talk a lot, right? I would say we've interacted. Right now, we're kind of pursuing like low-level details that aren't exactly on the same page, on the same things. We're very aware of the projects, and we want to collaborate where it makes sense, right? I'm super excited to potentially help. Like what I hope to do at Quansight is fund a bunch of labs. Quansight labs will probably only ever be 20, 30 people. My wildest dreams would be 100 people. Right? They'd be awesome. But I think the opportunity is there for thousands of people, 10,000 people, and I'd like to fund other labs. So I would love to partner with Ursa Labs.
There's API that allows you to measure performance, not NumPy, with respect to other packages.
Oh, sure, yeah. People benchmark these all the time. It's benchmarks it's challenging. You have to determine whether it's useful for you. But
there's API available to do that.
There's frameworks. I mean, time it. Profile frameworks. I mean, not really an API per se. There's frameworks for running benchmarks.
Brian?
So if you have things like data structures like trees and stuff like that, or anything like these Numba and XND, is that going to be able to do that?
Not as easily, right? Tree structures. Now, XND can define a tree structure, and you can define a function that works over that. It's actually pretty sophisticated. Now, it's not trivial. But you can define a ragged array in XND. You can define a ragged array of pointers, and as long as you write a function that can deal with that, you can do it, and you can register that. Again, will people do it? We'll see, right? How complicated do I want to be?
Yeah, I saw the Jupyter logo up there. Is that something that came out of your Anaconda labs? And does Numba and some of these other tools work inside of Jupyter?
Oh, of course. Yeah, no, Jupyter didn't come out of Anaconda Lab, but Jupyter Lab did come out of Anaconda Lab activity in conjunction with the Jupyter team. Like these are all cooperative efforts. These are very cooperative efforts. One thing I love about the open source community is you don't always get 100 people rowing in the same direction exactly, but at least you're aware of each other and you're trying to float approximately in the same direction.
Cool. So let's wrap it up there. But I would like to thank Travis for. So there's pizza on the counter over there, and I know what I'm going to be doing on my spare time, which is learning how to, given the circumstances, still give a fantastic talk, and also live coding, and taking that without any problem. So thank you. Enjoy.
What you don't see is that I used to be a lot better. 10 years of running companies instead of writing code all day. Thanks. Yeah, no problem.